is used as a fuel or illumination for that in the hackers' lamps. Not only for the illumination of lamps, but also in welding torch, as a fuel in the welding torch. You might have seen in welding stations where the metals are cut, where the metals are joined, particularly steel and iron. So we use acetylene is the fuel in the welding torch. And the major use of alkynes, apart from the fuels, we can use alkynes in polymerization, and will make the polymer, which is a very important. A polymer has that semiconductor property. And when it is iodine, means when it is react with the iodine, and it can produce iodine derivated polymers, which are good conductors of electricity. Good conductors of electricity we can use, and in most of the batteries we use these conducting polymers. So nowadays these have great importance in that battery preparation. So not only in conducting property, so other uses also, and alkynes are the starting material for the aromatic compounds, dyes, drugs, so many compounds, even aldehydes, ketones also prepared by using alkynes. Hence, it is very important, very necessary to discuss about alkynes and their preparation methods. At the first time, accidentally, alkyne means Ethyne was prepared by the scientist, Davis scientist, accidentally from potassium carbide. Potassium carbide is a salt. So from that potassium carbide, subjected to hydrolysis, he got Ethyne. Later, so the similar reaction conducted by the scientist, Berthelot scientist, who prepared Ethyne from the calcium carbide. When the calcium carbide subjected to hydrolysis, we can get Ethyne gas. So if you want to understand the preparation methods of alkynes, so we have to discuss. We'll discuss about in detail of the preparation of alkynes. So and so what are the preparation methods of alkynes? So here I listed out some of the preparation methods of alkynes, particularly. So for the discussion of preparation of alkynes, we should take one example of Ethyne. The Ethyne can be prepared from the calcium carbide. So crystals, calcium carbide crystals we have to use. So preparation of Ethyne from the calcium carbide. But first of all, we should discuss what is a calcium carbide. Calcium carbide is obtained from, how it is obtained first of all. So the calcium carbide can be prepared from calcium carbonate. When the calcium carbonate upon heating at high temperature, we can get quicklime. This is the quicklime, CaO we can get, and which is called calcination process. Already you have studied in metallurgy. So the Ethyne gas, Ethyne is the hydrocarbon, can be prepared from the calcium carbide reaction with the water. So, but now let me tell about how this calcium carbide is prepared. The calcium carbide is prepared from the calcium carbonate when it is subjected to calcination process. We get that CO2. The obtained calcium oxide, which is called a quicklime, this quicklime, when heated with the carbon, coke, carbon powder or carbon at high temperature, nearly the temperature around 2000 degrees Celsius temperature, when this carbon upon heating with the calcium oxide, quicklime, we can get the calcium carbide. We get this calcium carbide, crystals. So the crystals, and in this calcium, the calcium is already, this is divalent in the nature, and between this carbon and carbon, this is the structure of this calcium carbide here. Between carbon there is a triple covalent bond. Between the calcium and carbon there is ionic bond. So this is the structure of this calcium carbide. When calcium oxide react with the carbon at high temperature, so when at high temperature we can get this calcium carbide. So the obtained calcium, see, getting calcium carbide is not easy. So not at this at high temperature it is done. When this calcium carbide, so when this calcium carbide is subjected to hydrolysis in the water, this calcium carbide subject to hydrolysis, we can get calcium hydroxide, we get C2H2, ethane gas we get. And the first time this ethane gas was prepared by the scientist, a Berthelot scientist, from calcium carbide with the reaction with the water. So then Berthelot called this ethane gas commonly as acetylene. Acetylene is the gas, welding gas. Oxyacetylene is the welding gas which produces more temperature. So that is the major preparation method, and so from the calcium carbide, which is ionic in their nature. Now let us discuss about another preparation method from vicinal dihalides. As you know that vicinal is the structure where adjacent carbons having the halides. Look at this structure, vicinal halides. Vicinal halides are treatment with alcoholic potassium hydroxide. Alcoholic potassium hydroxide. Vicinal halide. First of all, what is meant by vicinal halide? The vicinal halides or dihalides are the halides where the two adjacent carbon having the halogens. Here you can see halogen. Here two halogens are present and adjacent to carbons. So hence it is said to be vicinal halide. And CH2Br and CH2Br plus KOH, when this potassium hydroxide, which potassium hydroxide, this is alcoholic potassium hydroxide. So when the vicinal dihalides are treated with the alcoholic potassium hydroxide, so upon heating, so then we can get, this is what we call dehydrohalogenation reaction. This is said to be elimination reaction, we say. In this dehydrohalogenation, one bromine from this carbon and one hydrogen, means from, for example, this is a beta hydrogen, this is a beta, this is alpha bromine, are removed. So from this means one hydrogen and halogen is removed from this vicinal dihalide in the first step, then we can get KBr. And we can get this halogen combined with the potassium, then hydrogen combined with this OH, then so water is eliminated and the potassium bromide is eliminated. So then we can get the residue, so alkene. So and we can get alkynyl halide, so ethynyl halide or ethynyl, so bromide we can get. This is two carbon compound is ethene, and ethynyl halide means bromide we can get. Once again, this compound is again subjected to elimination process in the presence of potassium hydroxide, or you can take sodium amide. So you can take by using sodium amide. So the sodium will abstract this bromine. So whereas the amide will abstract the, so amide will be abstracting the hydrogen. So when the NH2 abstracting this proton, it becomes NH3. When sodium abstracting this bromine, the sodium bromide, so then we can get The product is C2H2. The C2H2 we can get, this is called ethyne, which is a dehydrohalogenation process, which is elimination process, we say, elimination reaction. This is comes under elimination reaction. This is dehydrohalogenation reaction. Dehydrohalogenation means in this, so one hydrogen, one bromine halogen is removed from this. So dehydrohalogenation, as a result of this, the products we can get potassium bromide and water in this. From this reaction, what is eliminated? The final residue we get, final compound, the final product we get is that ethyne. So this is second preparation method of alkynes. The second preparation method. Okay, so and now, physical properties. So what are the physical properties alkynes exhibit? The physical properties, the first three members of alkynes are gases. The next 8 members are said to be liquids, and higher alkynes means alkynes having higher carbon atoms, more number of carbon atoms are solids, and all the alkynes are basically colorless. They don't have any color. So the first 3 members are gases, and next 8 members are liquid, and so more than means so 8 carbons alkynes are said to be solids. Basically they are colorless, we can say. And second one is ethene. So ethyne is ethyne has characteristic order, and and the pure ethyne is not having the orderless we say, but the impure means most of ethyne obtained from the industry will have that characteristic order, pungent order, because of the impurities present in that. Those impurities are phosphine, arsine impurities. They are lighter than the water, so immiscible with water, but soluble in organic solvents, we say, like ethers, carbon tetrachloride, and benzene. So in benzene, carbon tetrachloride, these alkynes are soluble, we say, but in water it is immiscible with the water, we can say. Let us discuss the chemical properties. The chemical properties of alkynes. The chemical properties alkynes. So if you want to discuss about the chemical properties of alkynes, then first thing we have to discuss about these alkynes is about acidic character of alkynes, we say. So alkynes, as you compare with the alkenes, alkynes are more acidic since they lose the proton easily because of the carbon which is undergoing sp hybridization is more electronegative and having the nature of electron withdrawing character of sigma bond. So that's why the proton can be easily removed. So this acidic nature of alkynes can be demonstrated, or so the acidic nature can be shown by reacting with metal amides, or reaction with the silver, reaction with the copper, reaction with the sodium metal. When sodium metal react with means sodium metal or sodamide. The sodamide is NaNH2 is a strong base when react with ethyne to form sodium acetylene. So, and in this, so we can get hydrogen gas will be liberated. Sorry. So hydrogen gas is obtained when the sodium metal or sodamide strong base react with the strong base when react with the ethyne, strong base react with the ethyne. Then the product we get is that sodium acetylene compound, and with the liberation of dihydrogen gas. Dihydrogen gas will be liberated. With this we can tell that liberation of hydrogen gas from the acid is with the reaction with the metal is said to be acidic character of alkyne, we say. So where alkenes and alkanes do not exhibit this acidic property, only alkynes exhibit the acidic property, we say. The hydrogen atoms attached to the triple covalent bond of the carbon are acidic. So if you observe this carbon between the carbon there is a triple covalent bond is there, and here there is a hydrogen atom. Hydrogen atom is attached to the sp carbon. This is the carbon that undergoes sp hybridization, and this carbon has more electronegative tendency, and withdrawing this sigma bond electron, then easily the proton can be easily removed. So that is the acidic property. So this carbon has sp hybridization, and this sp hybridization has more s character. Due to the more s character, more electronegativity, it behave like like fluorine or like oxygen and nitrogen. Then the proton easily can be removed. So when it react with the strong bases, or when it react with the metals like sodium metal or sodamide. So now let us discuss the reaction of the sodium metal. When sodium metal react with this ethyne. So ethyne, then sodium metal can displace the hydrogen atoms. You can see here the sodium hydrogen atom is displaced by the sodium, and if you take 2 moles and so 2 hydrogen atoms are displaced. Now you can see sodium acetylene, disodium acetylene, and hydrogen gas is liberated from this process. So so here if you observe the alkynes, triple covalent bond, alkanes, double covalent bond, and alkanes. In alkynes there is a carbon sp hybridization. In this s character is a 50-50 percentage, and alkenes having 33 s character. So and alkanes s character will be 25 percentage. P character is more in case of alkanes. So alkanes, here is the single covalent bond, right? And coming to this chemical properties, alkynes specifically undergoes electrophilic addition reaction. Electrophilic addition reaction means, so in this electrophilic addition reaction, reaction with hydrogen, so addition of hydrogen is hydrogenation process. Halogen, so reaction with the chlorine, reaction with the bromine, and hydrohalogenation when HCl, addition of HCl molecule to the triple covalent bond, HBr to the triple covalent bond. So all these comes under electrophilic addition reactions with the alkenes. So let us take one example, RC triple bond with CH. So RC triple bond with C, when react with the halogen excess in the presence of dichloro methane. So dichloromethane. So we can get means here the halogen atom means here H excess is the halogen react with this triple covalent bond. The halogen is added to this triple covalent bond. So then we can get tetrahalo derivated compound we can get. So when this halogen is added to this triple covalent bond, so we can get tetrahalo derivated compounds we can get. And now let us take example. First electrophilic addition reaction is hydrogenation, and in this hydrogenation process, the hydrogen molecules are added to this triple covalent bond. For example, this is the propane CH3 C triple covalent bond with the CH. When hydrogen is added to this triple covalent bond in the presence of platinum and palladium and nickel, we can get propene. So the propene further subjected to hydrogenation, then we can get the propane. That means alkynes can be converted into alkanes. So when they are subjected to hydrogenation process in the presence of platinum, palladium, and nickel. So, and this is also comes under electrophilic addition of hydrogen atom. We write electrophilic addition process, we can say. And so alkynes undergo hydrohalogenation process. In this hydrohalogenation process, we'll take example addition of HCl to this triple covalent bond. Addition of HCl to this triple covalent bond means between the carbon there is a triple bond is there. So when the HCl is added to this triple bond, then we can get first step we can get so alkene, we can get chloro-derivated alkene, we can get in the second step if you add HCl, then we can get so and derivated means dihalo derivated compounds we can get. 2 means, so here what we are adding means when HCl added to this triple bond, then bond polarization takes place. So here we will